Okay, I want you to think about tomorrow. I think most of you will start to prepare for exam on Sunday afternoon, maybe. Hopefully some of you will start early on tomorrow, even this evening. But I will be there. I won't be there to answer your questions this weekend. What would you do? Ask what? Ask each other. That's a good way to study. I encourage group study, but with social distance. Okay. What are other ways? I heard someone mention the videos I posted. Yes. And I want to talk about that. What is this? Okay, let me stop sharing here. Sharing screen. Sharing screen. Okay, that's weird. I don't know where this come from. Okay, first thing, all the examples we did in class. So in case you go over your own notes and try to figure out example 1C3, you're looking at your notes, that doesn't make sense right now. And if you want to try to figure that out, if your friends don't know that, but we do have videos on Moodle, videos about each single examples in your textbook. What you can do is go to Moodle, find that example video, watch it, figure out where you got stuck. Okay. All right. That's interesting. Enter an address at the top of the screen. Web browser. Let me try this. Yeah. Okay, now we're good. This is our Moodle homepage for our dynamics class. If you go under here, under chapter 1, take chapter 1. All right, there are some old lecture videos made by other professors. If you keep scrolling down, chapter 1, example 1A1 all the way to 1D6. Great resources to help you prepare for your exam. And we cover some of them in class, but there are much more than that. Every single examples on your textbook are here. So you can click them to learn how to do things. For example, chapter 3, the coordinate system conversion is a hard topic. Well, we have 4 videos here that can help you. Go check them out. If you feel like you're weak on cable and pulley problems, all the D's are good ones to look at. Okay, that's one way that can help you to prepare for your exam. Go over all the example problems. What are other methods you can use? Great, go through your old homeworks. Look at where you made mistakes. And what if you don't know what is right way to do it? You never came to my office, you never figured out why you did it wrong. And what? Yeah, how many of you ever click that? Homework solutions. Raise your hand if you click that. 2. Okay. You have questions? Okay. If I were students, I was doing homework. Dynamics homeworks are hard. Oh man, what is that tab right next to homework? Homework solutions. No one ever clicked that. If I were students, I would first thing that I would click, try to figure out, do we have just free solutions before I start the homework? Okay, of course we don't, I won't give you the free access before your homework. But if you click that, all the previous homeworks, we have solution videos for each of them, all the problems homeworks from 1A to 1D. And all the 1Ds are hidden because the homework is due today. So after 4 p.m. today, I will open all the access for 1Ds. But those are good videos for you to review what you did in your homework and where you made mistakes. Okay. What's other method you can use to prepare your exam during weekend? We have exam 1. How many of you have you ever looked at our Moodle page? What is under there? Raise your hand if you clicked that before. Okay, good. 2, 3. Maybe our exam 1 is just posted there. It's open to you, but now just only 3 of you click that. Now, of course, I don't do that. But if you click exam tab, we have sample exams with solutions. And you can practice if you want to. Then there's solutions where there you can compare. But those sample exams doesn't mean our exam gonna look like that on Monday. It's just something you can practice on if you want to. You have extra time. Yeah, of course, you can also go back to the lecture videos. We have recordings for all our lecture videos. And either you can go up, here is a link to the YouTube channel that all the recordings are posted there. If I have time, I will copy links down to here to make sure for all the lecture videos. But the YouTube channel is always open. You can go there, find the playlist for dynamics lecture recording if you want to go over the old lectures. So there are a couple of ways to help you prepare for your exam. And if you can find me during weekend, and those videos probably can answer your questions. Of course, today would be your last day to ask questions since I have office hour from 1 to 2, and I may give extra additional office hours after 3, depends if I'm my schedule. That depends on my schedule, but I will send out email to you if I can. All right. Now let's look at the quiz you did. Okay. Raise your hand if you don't have your quiz with you. What's your name? Taylor. Okay. Right here. Sorry, that's yours. Okay. All right. If you get 10 out of 10 or 9 out of 10, you're doing pretty good. Okay. If you get below 8, then don't worry. I'm going to go through this, make sure you understand everything from here, on this quiz. I think at least half of the class get 9 out of 10 or 10 out of 10. That's great. But my job here is to help the another half to get A's from exams. So let's look at the conversions. Coordinate system conversions. Okay. No. There you go. Okay. How many of you want me to go over the steps to set up the triangles, find sine, cosine, find the conversion equations? Raise your hand if you want me to go through details on that. Okay. If there are more than 5, I will do that. Raise your hand. I can see that. 1, 2, 3, 4, 5. Okay, since there are 5, let me go through that. I know the rest of you are pretty good on this. You can do other things, prepare your review other stuff if you want to. But let's look at this quiz. We have 2 coordinate systems. The red one is ER, E theta. What's the name of that coordinate system? When you say ER, E theta, the name of the coordinate system? That's polar, guys. The blue ones are ET, E, and what coordinate system's called? What's the name of? That's path. And we know the angle between them. Alpha, 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 alpha. Okay. We want to find out all the conversion equations. I'm going to start with ET equals something ER plus something E theta. Okay, that's a conversion equation we want to do. Like I said, we want to build a triangle with ET as a hypotenuse. This depends on the conversion equation. Since inside of this conversion equation, left-hand side is ET, so we want to use ET as the hypotenuse of our triangle. I'm going to use a different color. I'm going to highlight ET. This is going to be the hypotenuse of a triangle. And we're going to have other 2 sides of the triangle. One is parallel to ER. Look at your figure out where's ER, and highlight that one right there. Another side has to be parallel to E theta. Look at your coordinate system, figure out where's E theta, and draw a parallel line to form that right triangle. So this green highlighted area is my right triangle, and label where's your 90 degrees. This is my 90 degree inside of this triangle. Okay. Wow. If you look at that triangle, alpha is not there. Your next step is to find where's alpha. Where's freaking alpha in my triangle? That's important. So alpha, if you think that's alpha, that's not right. Your alpha, it's right up there. Angle right there is your alpha. Okay. So to help you visualize this, you can kind of link the triangle with your equations. So this side of your triangle, which is parallel to E theta. So this side is parallel to E theta. So that side should tell you the information about the blank in front of E theta. Another side of your triangle, that one is parallel to ER. So that side of your triangle will tell you the information about this blank in front of ER. Now let's go back to that triangle. You know alpha. How would you, what would you use sine alpha or cosine alpha to figure out this edge, which is the adjacent edge to that alpha? From trigonometry, that is cosine alpha. And this opposite edge, the side of your triangle, how would you use sine, cosine to represent that edge? That is sine edge, sine alpha. So that's how you find out the blanks. First, cosine alpha is that edge. We already built a link from that edge to this blank, So that is cosine alpha. And the first blank is sine alpha. Now you're done with sine alpha and cosine alpha. You must check your signs. Look at where's your ET. Your ET is pointing to that upper right direction. That is in the negative direction of ER, and also in the negative direction of E theta. Since E theta is pointing that way, E theta pointing that way, ER pointing that way. They're both as negative direction as ET. So both blank has negative signs. That's how I would find sine, cosine, positive or negative for those conversion equations. If you didn't get this right on your quiz, make sure you follow all the steps. On my YouTube channel, there's 6-step method. I also send you email links about this. Make sure you watch those videos if you still don't know how to do this. Okay. All right, then you can use the same method to finish the next conversion equation. En equals something Er plus something E theta. All right, build a triangle, use En as a hypotenuse this time. En is, where's En? En's right there. Highlight that as a hypotenuse of your right triangle. And one side is parallel to ER, another side is parallel to E theta. Okay. And highlight where's the 90 degree. So now I have another triangle right there for my second conversion equation. And the good thing is theta is given right inside of my triangle. That angle is alpha, sorry, not theta, it's alpha. So I'm good here. I can start to build a link. Since this is alpha, the adjacent side, it's cosine, and that is parallel to ER. So that tells me information about this ER blank. Another edge is parallel to E theta, tell me information about E theta. Since this edge is adjacent edge, so I know that must be cosine alpha. Another one is the opposite edge, that is sine alpha. And look at the signs. En is pointing to the positive direction of ER, but negative direction of E theta. So add signs, positive, negative. Now we're done. That's a triangle method. And that's just one set of conversion equations. If you get this set of conversion equation right, well, you can follow the same method to another set of conversion equation. Or if you're lazy like me, we can use that table trick. Build a table, then we can find the conversion equation right away. So if you build a table, ET, ER, E theta, EN, fill out the blanks, negative sine alpha, negative cosine alpha, positive cosine alpha, negative sine alpha. And we can write out another set of equation right away. ER is going to be negative sine alpha times ET plus negative cosine alpha E theta. And E theta are going to be, you read that table vertically. That's how I got the first equation. You read that vertically, you get expression for E theta. So negative cosine alpha ET minus sine alpha E theta. Okay, that's how I do the unit coordinate system conversion. Okay, once we have that, I think if you get 8 or below on your quiz, that probably means you don't know, you didn't get the second part of the quiz right. So if you look at the second part of your quiz, we're given A. Yep. We're given A is CER plus DE theta. So this is given. And this is in polar coordinate system. And what we want to find is V dot. V dot is in path coordinate system. So let's write out what is the equation for acceleration in path. That's V dot ET plus V squared over rho EN. Okay, so we want to use the conversions we did to help us find out what is this V dot. What can you do? This is what we given. Start from the given conditions. Is A equals CER plus DE theta. Can we convert that to path coordinate system? We can convert this polar coordinate system acceleration into path coordinate system by substitute ER and E theta with ETEN. Right, that you need to use the information from right here. Yeah, we know the conversions. Great, substitute ER E theta to replace this ER E theta. So now our A, C, R plus D E theta is going to be C times substitute ER, which is negative sine alpha ET plus negative cosine alpha EN plus D times negative cosine alpha ET minus sine alpha EN. Remember, this is our acceleration. Now we kind of converted our acceleration from polar to path coordinate system. But it looks really messy here, right? It equals something ET plus something EN plus something ET minus something EN. Let's combine them, make it look neat. Make it look like something ET plus something EN. So you can combine all the ET components, that is negative C sine alpha minus d cosine alpha, that's your ET, plus c negative c cosine alpha minus d sine alpha, that is for your En. Now we have this. We kind of converted a polar into a path. I think, at least I remember half of you get that right. Raise your hand if you have that. Okay. I think the question is, after that, what's next? I think a lot of you knows substitute that, but don't know what to do next. Okay, once you have this, you're one step away from the answer. All right, now let's just write down what are we looking for. We're looking for that v dot et. This is the equation for acceleration under path coordinate system. Like we mentioned, they're all accelerations for the same particle. They're equivalent. These two vectors, they're equivalent. How to make them equivalent? Or first, when you look at ETN, great. They're under the same coordinate system. And if they're equivalent, that means everything in front of ET for the first vector needs to equal to everything in front of ET for the second vector. That's how you make two vectors equal. Same deal for the EN component. Everything in front of EN for the first vector needs to equal to everything in front of EN for the second vector. These two are equivalent, they're equal. You can break them into two scalar equations. The first equation, it's on E, it's for ET component. Remember that it's not an equal sign, it's just a column. Everything in front of ET from the first vector should equal to everything in front of ET on the second vector, which is V dot. That's the first scalar equation. The second scalar equation it's for the En component. Everything in front of En should equal to everything in front of En. Okay, just want to make sure everybody understand this. You have two vectors. If they're equal, all of their components should equal. This is an important concept because we're going to use this again and again, over and over again in this semester. So whenever you have two vectors equal to each other, you can always break them down to two scalar equations. In this case, since we have two vectors in path coordinate system, ETN, and we break them down based on ET and EN. If we have them written in polar coordinate system, now we break them down based on the unit vector ER and E theta. Same deal for Cartesian coordinate system. If they're all in I and J's, we break them down I and J's. Okay, now if you look at the first scalar equation, what is that? V dot. It tells you the solution right away. You know, V dot equals this thing. That's the answer for the quiz, second part of the quiz. That's how we find v dot, the rate change of speed. Okay, any question here? Question?
Can you scroll up real quick to the first problem?
What?
Can you scroll up real quick to the
Yeah,
first problem?
of course. Is it too small? Now is a good time for you to ask questions. Since there's a very high possibility something like this will be on your exam. Okay, are we good here? Okay. Next, now we're done with quiz. Well, one more thing I want you to look at. So when I went through your quiz, I found some common mistakes. I can show you, then you can tell me what is wrong. Okay, so someone have this? This is from second part of your quiz. Okay, what is going on here? What's wrong with this? Who can tell me what is wrong with this? And how do you correct this? Anybody can tell me what is wrong? What? Yes. I can tell you're trying to plug in, replace E thetas with ETN, but where's your ETNs? I think when you substitute this, you should have EN, ET, something like that, right? From the conversion equation. But make sure you have that unit vector with you when you do the substitution. And also, when you look at this, on left-hand side, you have this vector. But what is on your right-hand side? You have scalars. So that's not equation. That's one common mistake I find. Another one is, okay, I would just simplify this. So someone have C equals negative sine E alpha ET plus cosine alpha En equals, let's say, V dot ET. Okay. Maybe that's not exactly what you have there, but something similar. That looks all right. We have ETN, so vectors, kind of good here. But what's the next step? Just throw me off. So, okay, I think we're trying to find E dot, right? That's pretty simple. Let's just put this guy, divided that ET on both sides of equation. Boom. We have solution for V dot. What's wrong with this? Okay. First, I can tell you, this is no. Never multiply or divide univectors on both side equation. No, it's not allowed. It's not correct. Nothing, no one ever taught you to do that. Don't blame to your math teachers. He never told you that. You cannot divide by univectors or times univectors. You can divide by number on both sides of equation, but you cannot do that for univectors. Keep that in mind. Okay, all right. We have 10 minutes left. Any questions you want me to go over? And if you don't have any suggestions, I would talk about same thing, another kind of a big category of problem. Find v dot, which is a rate change of speed. In that quiz, it's also to ask you to find b dot, but we know that angles between two coordinate systems, we can do conversions. What if we don't know the angles? We can't do conversions. What to do? So there are a couple problems. It's about that, to find v dot, but we're given something about speed, something about velocity, and we probably also know something about acceleration. Then we're trying to find what is v dot. And those informations could be in polar or Cartesian. So we're kind of trying to find what is path by using the information given in Cartesian or polar. So if you see problems like this, and that reminds you, you probably want to try dot product. You did something similar in one of the homeworks. Because this is on your page 30 in your book. And so dot product can help you find out what is v dot. So v dot equals a, which is acceleration, dot product et. That's it. If you know acceleration, you know unit vector at, you can use dot product, find the v dot right away. But in most of the cases, et is not given directly. You have to go through some steps to find out what is et. So how to find et? Et can be found by using the information about velocity and speed. Et can be found by using v, which is velocity, divided by speed, or you can add a magnitude there. That will help you find at. So once you have et, first, is this et a scalar or vector? If you do an operation like this, you have vector divided by some scalars. Would you end up with a scalar or vector? For example, if v is 6i plus 10j, what is v divided by 2? 3i plus 5j. Is that a scalar or vector? It's a vector. So you would have a vector from this equation. Et is a vector, which makes sense. Et should always be a vector. And you can plug that vector back into this dot product. Dot product requires you have two vectors. vector A dot product vector ET. Then you will get a scalar. So what you end up with is a scalar for V dot, which makes sense. The rate change of speed V dot, it's a scalar. And that was a hard homework, one of the hard homeworks in 1C, I think. All right, and the next thing, 5 minutes. Yes, let's do a practice. That's something about ropes and pulleys. Well, I don't think ropes and pulleys are hard. But first practice we want to do is, what is the time derivative of, let's say, 3sa squared plus 6? What is this? What's the time derivative of this? We did some practice in class, but if I just change some numbers, I switch this SA to SB, replace 3 with maybe 10, give a new look. Do you know how to do it? So I would make it easier to look at. The square root scares me. So I would put square root away. Make that as just 1/2 of this 3sa squared plus 6. Then I can do the time derivative of that. 3sa squared plus 6 1/2 dt. And what I would get is take the 1/2 down and make sure that 3sa squared plus 6 has 1/2 minus 1 over there. And now you want to take the time derivative for everything inside of the parentheses. Inside of that parentheses, we have 3sa squared plus 6. 6, it's a constant, so we don't need to care about that. But 3sa squared, time derivative of that is 3 times 2 times sa times sa dot. Here, I think there are always mistakes there. SA times SA dot. So a lot of you will miss that SA dot or SA. And this would be in your cable and pulley problems. And for cable and pulley questions, okay, one question is, if we want to list the length equation for this pulley problem, which length are considered as the extra term instead of our equation? Do we consider the length right here? No, we don't care about that length. That we only care about the cables that wrap around pulleys. But do we care about this part of the length? So that part of the length wrapped around the pulley, it's a constant. So those two would end up with the extra term instead of your equation. And all the lengths, the variable length you will care about is, let's call it S1, S2, S3. So S1 plus S2 plus S3 plus extra terms. And just for this drawing here, that S2 is also constant. No matter how your block is moving, S2 is fixed. That's a two fixed point. So the only real variable here is just S1, S3. So if you write your length equation, it's actually just S1 plus S3 plus some extra. That's enough. Okay. That's all for today. And remember, office hours 1 to 2 today. And if you need help, let me know. But well, weekend is on your own. So good luck. I will see you guys on Monday.